Welcome, everyone. I want to talk about the real engineering experiment we had at Dyson. A story is about why AI-generated code kept failing and what it did with that. So everyone is talking about AI-generated code, and honestly, the results can be impressive. So let's start off the version of AI coding that everyone knows. You can open Copilot or any other coding assistant tool. So you paste a simple prompt. You want to build a login screen. So you mention SwiftUI, you mention modern buttons, clean and reusable code. So it sounds reasonable. You can do a login screen, a checkout flow, a setting page, or whatever you want, and you can get a working SwiftUI screen in a second. So the code compiles, the UI looks good, and you think you're done. And all of us know this moment. So you open a PR, you feel confident, the UI looks good, everything works. You think that should be a quick approval, a quick win. And then someone who knows the system the best joins the PR, a principal engineer. And suddenly you feel a bit stressed because in the moment, everything changed. During code review, we start acting like we all have PhD in computer science. And the comment starts. One comment, next one, and 10 more. Why are we using this component? This doesn't follow our design system. We already have abstraction for this. So these are not the nitpicks. There are signals that the generated code is ignored by AI. AI is ignoring our shared knowledge. It shows the cost of the duplicated abstraction, duplicated components, and broken guidelines we have in our company. So every code reviewer can recognize this is not our code. This is not how we write code in our company. So it was going well. Build succeeds, preview looks good, but then, well, change is requested. And suddenly the energy drops and you realize something important. AI was fast, we weren't. So the real question is why? And to answer that question, so the question is why, and is it a model? Not really. Maybe a prompt, okay, it was not ideal, but you can improve it. But still, I don't think it was the prompt. It was missing the context of our guidelines. To explain why, let me take you back a few years ago. Before MCP became part of this conversation, before AI, okay, maybe not that far, but before all the hype. So before the hype, we had a business problem in Dyson. So Dyson competitive advantage comes from innovation. The faster we can bring new products to customers, the better for our business. Every product brings new screen, new journeys, and new functionalities. More products means more teams, and more teams, more interfaces or more screens. And as we add more products, more teams will be building more interfaces. A single team can be aligned by a conversation, but many teams requires a shared system. So our customers doesn't really care about our organization chart. And while our products might be different, they have different features, customers still expect to feel them like Dyson products. If you own multiple Dyson products, they should feel connected. Different product, different features, but one ecosystem and one experience. But consistency was also not enough for our business. At the same time, business wanted us to move faster because our competitors every year also launch many products. So time to market matters. And the design system was one of the initiatives that we took, and it helped us to achieve both. It allows teams to build screens faster, and it allows customers to have the same shared experience across different products, so it doesn't feel like you have a separate app for every product. But it wasn't because creating buttons are difficult. It was because consistency and scalability is difficult. We wanted teams to spend time creating features and new products, not rebuilding buttons or adding some new spacing rules. So design system gave us reusable components, shared patterns, shared language, and also faster development. And it worked mostly. Even with design system, people still have questions. Which component should I use? Why this abstraction is preferred? Actually, why pattern A is better than pattern B? So the questions always existed, and the answer also existed. They were in documentation, in examples, in design guidelines, in many different places. So knowledge was distributed, and not everyone knew about it. So design system is actually a knowledge system. And the challenge isn't creating the knowledge. The challenge is making sure it's used correctly. And you don't need to work at Dyson to have this problem. Maybe your company doesn't have design system, and it's fine. But you definitely have your own conventions. You have your patterns, and you have code reviewers. Someone joins and says, that's not how we do things in our company. And that's why I think about design system differently now. So then we are back when AI arrived, and it started making the same mistakes. Not because it was bad at SwiftUI. Actually, AI is quite good at SwiftUI. The problem was different. AI knew the language, like is it Swift or Kotlin, doesn't matter. But it doesn't know the company. AI, in our case, didn't know Dyson. So, like I said, any language is known to AI, but it knows nothing about your conceptions, about your design system, architecture, or guidelines. And that's where the journey starts. We often say that AI generates generic things. Everything looks the same images, sentences in the same style. And yes, that's true, but only partially. Because AI creates a generic software because we provide a generic context. And that's the problem. So when the context is shallow, the output is also shallow. But when you give a context, like your architecture, your design system, all your constraints, then something changes. And it becomes your software. So the first idea for the design system was actually very simple. If AI doesn't understand design system, let's give it access to Figma. So there is a Figma MCP. They offer it out of the box. And I will talk how MCP works. I will talk later about it. But you can think about it as kind of an API for LLMs. So it's very easy to connect. And actually, Figma gives you a prompt that you can simply paste to your Copilot and says, implement this design from Figma. And you can paste the link. And everything works with the Figma API under the hood. And visually, it matches our design system. So the result improved significantly until we looked on the code. So the UI looks correct, but implementation doesn't. Sometimes AI found the right token, sometimes doesn't. Sometimes it creates a new constant, sometimes use a magic value. When we take a look on the code, you can see some magic values on the VStack. And actually, we don't use VStacks in our design system. We have our own containers that define the spacing between all the components. It defines how the screen is structured. Also, it takes just the font from Figma using a string. We, of course, have our own abstraction on using the Dyson font. And we don't have constant, which is called label text size or either age-free text size. The names are different in our code base. And these are actually different between iOS and Android because the platform has its own conventions. And if you take a look on the button, which should be at the bottom, it's actually not a button. It's an age stack with an image and a text using, well, this is right. It's Dyson color content, but the rest is incorrect. So there are some hallucinations in our code. Like I said, the screen looked right. The code was wrong. So why Figma wasn't enough in our case? And we discovered something important. Figma and code were never identical. And that is the first lesson. Designers lived in Figma. Engineers lived in codebase, in SwiftUI, Compose, and both sides has its own abstraction. So Figma actually defines how it should look like. You have some frames, rectangle, image, and text. From the engineering perspective, we have our own abstractions that didn't exist in Figma because it's not needed there. Designers don't need to take a look on the code. They use the frames and the design tools. And it's not because anyone made a mistake. It's because we were looking at the same problem from a different perspective. Figma tells AI what it looks like, but now how we build it. And then we realize we need to provide more context and how to connect our components to Figma and our AI workflow. So there is also Figma Code Connect API that allows you to map your components, and it's also pretty straightforward. And you can also map different variants, different colors, sizes, and you see everything as a preview in Figma. Whenever you click on a component, you can see the code snippet on the right side. So we thought the problem is solved. So that was the code we had previously. For the button, you can see the age tag, image, and the text. And it becomes something like this. It looks much better, and it fits our design system. So we are done, I think. So we provide more context. Previously, we have only agent and Figma MCP. Now, we provide even more context by adding our components and mapping. And the difference was visible on the screen and in the code. No more random buttons or hallucinated components. And like I said, we think it's done. But as you can imagine, it's not done yet. So yesterday, I had a chance to meet all the speakers. And they asked, like, oh, so you work for Dyson. How is it working in a product company? By the way, how many of you work in a software house? You can raise your hand. OK, and how many of you work in a product company? OK, so I have experience in both. In the past, I worked for software houses. And when in a software house, you need to convince your client to do something. In the product company, you need to convince all the stakeholders. And I don't want to go into discussion which one is more challenging. But I spoke to one of the engineering managers in the company, and he says like, oh, go to this principal. He invented all the design system, and he will give you a valid feedback. And of course, it's like, I need to convince him this is worth doing. And so he looked on the output and said, OK, but it might be wrong. It doesn't understand spacing rules and our tokens. And honestly, I was like a bit upset. Like, of course, it might be wrong. It's AI. Everywhere where you use AI, it says, this is AI-generated content. It might be wrong. Check your answers. So I said, yes, technically you are right. But look what improvement we made. So it was never about eliminating the mistakes. It was about reducing the chances AI is wrong. So after a bit, I understand it's not about spacing. He wasn't talking about tokens. He meant the knowledge. So Code Connect fixed one problem, the mapping of the component. The H tag became a button. But still, the agent doesn't have our organization knowledge. It's still missing some tokens, spacing, and most importantly, our conventions. So it doesn't build the software in a way that our software engineers would build that. Again, the screen, correct. Components, correct. But the structure is wrong. So the missing knowledge was not in Figma. And it wasn't in Code Connect, because Code Connect is only about component mapping. Everything was in our engineering practices. For years, our engineers built different abstractions, different components, composition rules, architectural patterns, and AI doesn't know anything about it. So then we decide to stop exposing more design content, and we start thinking about engineering context. And that way, we decide to build our own MCP server that can serve some documentation about our container usage, layout patterns, composition rules, and engineering conventions. And something that is equally important, we also provide real examples to MCP. So in our app, we have some kind of a debug screen where every engineer can enter, and they can see examples of how our design system component works. They can try different variants, and of course, they can browse the code and see how it should be implemented. So now the AI understands the concept and also has a real scenarios, how we use our components, how we use our containers in our code base. It's not documentation, it's implementation knowledge. So the workflow looks like this. The AI engine can talk to our design system MCP server, and we expose all the knowledge through the resources, and also we have tools. So the easiest way to think about MCP is it has its own resources. It's something that AI can read, like, for example, how to use primary button, or maybe when to use primary button, when we should use the secondary button instead. It becomes a source of truth. In our case, we have our documentation for design system also in Figma. So we use Figma API to map it into a markdown file, and then we expose it as a source of truth for AI. And also, we have tools, and these are things AI can do. Like, it can search for examples, how we actually use our primary button. And this is kind of the dynamic knowledge. So documentation says what should happen, but the real answer for code is what actually happens. We have our preferred wrappers, preferred abstraction for different cases, some composition patterns. So for the first time, the code actually starts looking familiar. We have our containers, we have our text fields, we have our buttons. That's something that a Dyson engineer could write. Now, it really looks like our code, sometimes. So there's one missing thing, and it's one skill to rule them all, and in the context bind them. At this point, AI had access to Figma, to Code Connect, so mapping of our components, documentation, containers, examples, everything needed. So knowledge was no longer a problem. The process was the problem. We taught AI what to know. But as our onboarding for engineers teach two ways, what to know and then how to work. And we never taught AI how to work. So that's where we used skills. And we define a single skill that defines the whole process. It's first to read Figma design from the link, then use Code Connect and map it to our components. Then go through our documentation and validate everything. Then check the container usage and wrap everything in our containers instead of using magic numbers. Search for examples, and then generate SwiftUI code. And at the end, review your work. That gave us a complete workflow. So MCP provides the knowledge, and skill define how AI should use it. So what we learned? Figma, it's only about what looks right. Code Connect, use correct components. Custom MCP, understand our patterns, and skill, use everything consistently. We put it all together, and we have complete workflow. So it starts with the design, then it goes through AI engine, then go through the skill, and skill defines how it should use a Figma MCP, Code Connect, and our design system MCP. And that is finally SwiftUI view that belongs to our organization. That is something I can join to the code review and say, that looks correct. That's how we do things in Dyson. So again, we are again with our prompt. The same one which I copied from Figma MCP. And now everything builds, and it looks good, exactly like our design. You can take a look on the code and see it used our containers. It used the text field, secure text field for the password, and the correct button style for both buttons. And it's all wrapped in the container with button buttons. So we are sure that it also has the proper spacing between all the components. And now we are done. So the model actually didn't become smarter, but the context is much richer now because we provide all the knowledge we have in our organization, and we think it might be right for creating screens using our design system. Each system is useful, but none of them alone would solve the problem. It required a few steps. Like I said, it was Figma first, then Code Connect to determine which component we should use. Engineering documentation, container guidance, code examples, and skill. So it was no longer a challenge. How do I connect AI to my system? Because it's pretty straightforward. It's how do we expose the knowledge to AI? And once we did that, the outcome of our prompts become much, much better. So the knowledge is actually the real asset. Some of the knowledge lives in Figma, so in Code Connect, some in documentation, and it's very important to understand how do we expose it to AI. So we use MCP, Code Connect, and skills. The real challenge, it's not the model. Like a new model comes every day. You can think, what is better? Is it Gemini? Is it Claude? But it is about the context. And to say that AI doesn't ignore your guidelines, it simply doesn't know them. And I couldn't finish this presentation in another way that's with the approval from the principal engineer. Thank you very much.
So one more time, dziękuję bardzo, Oskar. Very, very helpful session, even for me. We have a couple of questions from you. Great crowd. So I will read them for you, maybe, buckle them together. So one, most obvious one, I would say, is about the knowledge. So the question is more or less about how you optimize the size of the window to prevent two things. Main is the token spent and cost footprint, and second one is how you prevent the hallucinations.
Yeah, so it's a tricky thing, and it's actually about context engineering. And the question about tokens, so the question is, if you don't expose the knowledge to AI, you might actually spend more tokens by fixing what AI produce, or you might spend more time. So it is difficult to measure, and for us, it's still the initiative that is ongoing. So I cannot provide you hard numbers, but we think that providing the right knowledge. So that is why we have some examples, because we found out that the documentation itself, it's not enough. It really needs to have the context, and that's why we use the MCP and we use the tools. So it's not just the retrieving the information, retrieving the documentation, but you must try to provide the right context. I know it's like saying you just need to provide the right context. It's just try and learn and see what actually works for your organization the best. Because you can also provide some context in Copilot instructions, and that's also fine. But I think that was also a part of the question. You might be careful to not have the overflow of the context. So it's always the point of finding the right knowledge. If you want to build the primary button, you care only about the primary button. And that's why you have the MCP.
Yeah, maybe a related question coming from some of you guys. Why you prefer to building a custom MCP server instead of MD skills? So how you decide whether you will introduce a new MCP tool or you will create a new MD skill?
Yeah, so I would say it's something that works together. So like I said on the presentation, the skill defines how to do things, in what order, what is the process, while MCP provide examples and the knowledge. So these are like the skill orchestrates both MCPs and Code Connect. You have a few components, a few things in your AI workflow that must work together. And I can give an example. So I recently built an agent with a skill, and the skill is to define how I do code review. So it's because I don't really have always time to do the code review. So I built a skill that first the agent analyze all the code reviews I did in a half year back. And based on that, it defined a skill, how I do the code review. So it's about how. And then I put it into the agent, hey, use this skill. So you will see how I use, how I do the code review. And I gave it a bit more of the context about some generic SwiftUI guidelines. So it's about sharing the knowledge with the process, or knowledge in the process.
Yeah, two questions related to the closing or, extending the feedback loop. The first one, also obvious, do you solve a problem of the AI agent to completely validate the UI after the, create a change?
So if you mean if you have an agent that checks the visual code,
exactly.
No, we don't have it yet. So yeah, I don't know.
Which answered the second question related to it, and it was like whether the whole feedback loop is completely automated, so whether there is still human in the loop or not. I guess yes, human is in the loop. He has to, at least check the result, right?
Yeah, I mean, definitely human is in the loop at the code review, right? And also, I think most of us use also the agents to do the self-code review before we push it to the branch. So later, everyone else can use their own agent to do the code review. And at the final step, human takes a look and approve or request changes.
Yeah, a couple questions related to the how you maintain the resources, where they are stored. If you, combine the documentation of the technical skills together with the product documentation, etc. Mm-hmm. So where and how?
Okay, so like I said, we have the design system documentation in our Figma. So these are simply pages that are the designs, and we use Figma API to map it to a Markdown file. And we store it in our MCP server. We actually have the pipelines. So we have defined the JSON structure that defines all the tokens or the text that should be defined in the Figma. So whenever you want to update the documentation, you update the repo, and and it pushes the changes to Figma using Figma API. So it renders as a page, and then from that we get the Markdown file.
Yeah, perfect. There's also one question related to the custom MCP, likely from the guys who are about to start with it. And the question is, how difficult is, to set up and build custom MCP?
So setting up the MCP server is very straightforward. You can simply visit the website for setting up MCP. There are frameworks ready to use in TypeScript, in JavaScript. I believe there's also Kotlin, and basically any other language you would like to use to have the server. So it's pretty straightforward. I don't think having the MCP server is the challenge. The challenge is to provide the context, the knowledge to AI, the right context.
Yeah. And likely the last one, because the motto of this conference is craft over hype. And the question is, are you automating yourself out of a job?
Yeah, so like I said, I have my own agent that does the code review, like I would do. But in a way, how it works. So it highlights me the critical part, some nice to haves, and things I should review on my own. So there is still human in the loop, and I believe there will be always human in the loop. Like AI is a nice tool, and it can provide a lot of things, and our work can be done in a very efficient way using AI. But also with the tokens becoming more and more expensive, I think that will be the engineering job to use AI in the right way.
Yeah, and because I love our beautiful crowd, so one more, and that's why MCP and not CLI? Why not, command line interface, and why MCP?
So if you mean you want to provide a giant prompt in CLI, that would be pretty challenging. You don't know what you actually need in your prompt. So of course you can build a big generic prompt that you will use like every time. But again, it's back to the question we had before. You might go outside of your context window. So actually, you might see more hallucinations, and that would be a problem.